Hello everyone again. Welcome to the second last lecture for our Lab 8, and we are going to talk about the ECG, electrocardiogram, and exercise. This is a really important and interesting one, and I hope we'll all have some great time together for the next maybe 25 to 30 minutes or so. Now, as we have already been discussing, we'll talk about the presentation outline first, that what and why we should know about ECG. Then I will walk you through to an overview about the electrocardiogram and talk some of the very key points about those complicated waves which we see on an ECG paper. Now, the things which are highlighted in red are the key objectives for this presentation. You have to do the ECG lab placement for your practicum, so you should be many times aware that ECG lead placement is the most important thing you want to learn today. We will also talk about the types of ECG electrodes, and we will go through the lead to ECG recording and calculation of heart rate. This is again really important because you're going to do it on your data sheet today. And at the end, we will see that how ECG changes with various pathologies as well as during exercise. And as we have been doing it throughout our lab, the last thing is to go through the data sheet 16.3. So let's make a start. As we have been talking throughout this lecture series, that why should you know about ECG, or what is the advantage of knowing about ECG? You might have a lot of things in your mind, but the most important things which I feel you should know are that ECG tells you about a bunch of various things about our heart. The first thing is about the anatomical orientation of the heart, that whether the heart is present on the left side, which is normal, or it is there on the right side, which happens in some people. This is known as dextrocardia. It also tells us about the relative size of the different chambers of the heart, and in a lot of heart failure pathologies, we have left ventricular enlargement, which is left ventricular hypertrophy. We can diagnose it with the help of an ECG. The second point says that it also tells us about the disturbances in rhythm and conduction, which technically means that we can diagnose different kinds of heart blocks. For example, it is the heart block where there is a pathology where the heart is not conducting impulses normally, or it's also possible that we have different kind of arrhythmias. It can be an atrial flutter, it can be an atrial fibrillation, or a ventricular fibrillation. Now, the third and the most important thing which we can diagnose with the help of an ECG are the ischemic changes in the heart, whether it's the big myocardial infarction, or it's a myocardial ischemia, or if it's an angina or different variants of angina, we can diagnose all with the help of an ECG. Last, not the least for sure, but we can also diagnose the effect of various drugs on the heart, especially which are inotropic by origin. So if we summarize this whole slide, we can talk about the anatomical orientation, different size of the heart, chambers of the heart. We can diagnose arrhythmias, we can diagnose ischemic changes, and can appreciate the effect of drugs on the heart. Let's move on. I always wanted to highlight and let everybody know two big things whenever I am teaching ECG. The first thing is that ECG is the recording of the electrical activity of the heart. It is not the mechanical recording, which means that when our heart is pumping blood like this is not the part which is recorded. Once the electrical impulse passes through the heart, through the conductive tissue of the heart, then the changes which are taking place, and if we are recording those changes on the surface of the skin by putting electrodes or whatever, that recording is technically known as ECG. And this is what I have tried to highlight using two different definitions, the one at the top and one in the second half of the slide. It is, again, I'm repeating, the electrical activity of the heart, which is recorded on the surface of the skin, is known as ECG. I want everybody to be extremely sure what we are recording once we do it in our lab. Now, this is the big thing coming up. ECG lead placement, because you are going to do it for your practicum. Now, in total, you have to place, as you have seen that on the slide, 10 electrodes on the chest, which represents a total of 12 conventional leads. So you have to put 10 electrodes in the form of stickers at different points of the chest of your patient. And how and where we are going to put all of those, this is coming up. But before you are putting those leads or the electrodes, I want you to know that there are 3 types of leads which we put on the heart with the help of these electrodes. So physiologically, they are divided into 2 groups, the bipolar one and the unipolar ones. So the bipolar leads are the ones where both the terminals are recording the changes, and the net potential or the electrical change between the 2 electrodes are recorded as the final recording. If we talk about the unipolar ones, these are the ones where one of the terminal, the negative one, is always neutral or at 0 potential. It's only the positive terminal which is recording the electrical changes. So which means that whatever reading is there for the positive terminal, the other one is 0, so that will be the final one. But in the case of the previous one, the bipolar, both the electrodes are recording, and the difference between the 2 is the final recording. So we have, out of 12, 3 leads. Lead 1, lead 2, and lead 3, which are the bipolar leads or the standard limb leads. And we are going to place electrodes somewhere here, here, and beneath these ribs, 4 different places to get these bipolar leads. If we look at the unipolar ones, we have 6 chest leads or precordial leads, which are V1, V2, V3, V4, V5, and V6, and we put it on the chest somewhere between the ribs and around the sternum. And we have 3 augmented leads, and these small a's which are written before these v's tells that they are the augmented ones. As the name suggests, they are augmenting or enhancing or increasing the actual potential. And technically, the leads which we have put beneath those collarbones too and beneath these ribs, as we'll see later on, the combination is again used by these augmented leads along with the bipolar leads. So if we summarize this slide, we are going to put 10 electrodes on the chest, which represents 12 leads. 3 out of 12 are bipolar, both the electrodes are recording. 9 are unipolar. Out of 9, 6 are chest leads or precordial leads. 3 are augmented leads. Now, before I start talking about the placement, I thought it's a good idea to jump into some of the very key concepts which I'm really hoping will reduce some of the ambiguity about the terminology as well as the conceptual basis of ECG lead placement. For example, what is the difference between a lead and an electrode? It's pretty simple. The top definition says that a lead is a combination of two electrodes. And now I'm guessing the previous slide will make a lot more sense to you, because it says that if it's a bipolar lead, it's both the electrodes are recording the potential. So none of them is neutral, both are recording, and it's the lead 1 or lead 2 or lead 3. If we talk about the unipolar leads, -1 is always neutral or at zero potential. So it's the positive one which is recording, and you can ignore the other one. So because only one is recording, that's why it's called as the unipolar lead. Now, this is what I've been talking for the last 5-7 minutes, that if it's a unipolar chest one electrode is exploring the positive one and the other is neutral, or the 0-1 which is on the chest, and we are here talking about the 6 chest or the precordial leads. Bipolar, just I'm reading what I've talked before, it records potential differences across both the electrodes, both the positive as well as the negative one. And augmented are unipolar. The difference is that it's exploring the positive part of the electrode on the right arm if it's an AVR, on the left arm if it's the AVL, and on the left foot if it's the AVF. So basically these terms, R is for arm, R is for right arm, L is for left arm, and this F is for left foot. The one which is there on the right foot, or actually on the right side of the rib, is the one which is the grounding electrode, and it's not recording anything. It is just to reduce the differences in the potential or the disturbances in the electrical potential. Now, these are the 4 electrodes which we will put on the patient's chest first. So lead 1, we will put 2 stickers. The first beneath the left rib, the left clavicle, and on the other side, we will just put a sticker below the right clavicle. So we have the LA and the RA. Then we will put 2 more stickers, one somewhere below the costal margin and beneath, just below, whenever the ribs are going to finish, somewhere between the 9th, 10th, and 11th rib. And this is the left leg one. And this one, the RL, this is the grounding electrode. It is not recording anything. And what I mean by grounding and why I'm saying it's not recording anything, I just want you to see this diagram. We are not recording anything with this electrode. So technically, out of these 4, the 3 electrodes are making a combination for lead 1, lead 2, and lead 3. And you can see here that lead 1, the positive is on the left arm, negative in the right arm. This is what it says. And both the electrodes are recording the differences. That's why it's a bipolar one. Again, if we see the lead 2, the positive is on the left foot and the negative is on the right arm. So both the electrodes are recording the difference. So this is again a bipolar one. And the same thing is happening with lead 3. So the idea is that 4 electrodes are placed, 2 beneath each clavicle, 2 below each costal margin. 1 of them is grounded. 3 of them are recording the potential difference for the bipolar leads. This is a kind of recording which you're going to see. We'll talk about the waves in just a moment, but you just have to remember that these longest and the tallest waves, or the ones which are really narrow and tall, these are the R waves. So this is the first R wave, second R wave, third R wave, 4R wave. This is lead 2. This is more long than the lead 1, and lead 3 is extremely similar to lead 1. So once we have all the 12 ECG lead recording as a paper, which I'll give you after we record it in the lab, you can always see that lead 2 has the tallest R waves as compared to 1 and 3, which are pretty similar. Now let's come on to the chest leads. We are done with the three unipolar leads, and we have already put 4 electrodes on different parts of the chest below the clavicle and below the costal margin. Now we are bothered about the unipolar chest leads. This we are going to place at different parts between the ribs in the inner costal spaces. This placement is very similar to the one which we have talked about, the heart sounds, where we are putting the stet. Here again we have to identify the locations, but instead of putting the stet on the chest, we are going to stick the electrodes. First go with V1. V1 is placed at 4th intercostal space right to the sternum. Again, the interesting part is that V1 is the only electrode which is placed on the right side of the chest. Everything else is on the left side because we have heart predominantly there on the left side. It's only a bit of a right ventricle which is there on the right side. So we just have one electrode to measure its activity. We will place V2 just to the opposite of V1. So it's there on the right side. We just place it opposite to V1. So we have V2 in the 4th intercostal space, but on the left side, just near to the sternum. Then we will put V4. We will not place V3 before V4. And V4 is there in the 5th intercostal space on the mid-clavicular line. So this place is pretty similar to the location of the mitral or the bicuspid valve, if you remember from the auscultation of head sounds. 5th intercostal space, mid-clavicular line, and here you go for lead V4. Now we have 1, 2, and 4, and please put 3 just in the middle of V2 and V4. So it's midway between V2 and V4. Now we have to put V5 and V6 exactly in the same intercostal space, that is the 5th one. But the difference is that instead of mid-clavicular line, we are putting V5 on this place, which is the anterior axillary line, which is actually the anterior axillary fold, which is formed by the muscles of the chest, the pectoralis muscle. And V6 is just behind V5, and this one is midway between the anterior axillary line and the posterior axillary line, and this midline is known as the mid axillary line. So the idea is that 4, 5, and 6 are there in 5th intercostal space, but they're at the mid-clavicular, anterior axillary, and mid-axillary lines respectively. You have V3 between V2 and V4, and both the V2s are there in the 4th intercostal space on the right and left side respectively. So I think it's pretty simple. We will always have that picture with you once you are placing the electrodes, but I really want everyone to remember the anatomical location, because this is the thing which you need to verbalize in your practicum while placing. So you are expected to say, okay, I am placing V1 on the 4th intercostal space on the right side. Now I'm placing V2 on the 4th intercostal space on the left side. Now I'm placing V4, and now I'm placing V3 between these two, and now I'm placing V5, which is on the anterior axillary line, and I'm placing V6 on the mid axillary line in 5th intercostal space. So you should remember the intercostal space, the line, and which electrode you are sticking. So these are 6 plus 4. We have placed 4, 2 beneath each collarbone and 2 between each costal margin. 1, 2, 3, 4, and 6 on the chest, and you are done with all 10 electrodes placement. This is a kind of a recording which you'll get on the ECG paper. You should not bother about the different sizes and different deviation of these waves on the paper. I just want you to know that if we move from V1 to V6, you can see that R is inverted in V1, then it just got a bit short, and then it's equal in V3, and then in V4 this becomes big on the positive side, and then it continues to become small as we move from V4 to V6. And this change in the shape of R wave is known as R wave progression. Now, this is a kind of a design which you see with the augmented leads. The idea is just to, familiarize you that this AVR always have an inverted wave normally. So if this one is positive, which means we have some kind of anomaly. Okay, now as we are done with the ECG lead placement, the first part or the first objective of practicum is done. Now we will move on to the lead 2 ECG recording. And this is the part which is concerned with your data filling of your data sheet in the lab. This is pretty simple. You might have heard a lot about ECG lead papers, and this is a classical picture of the lead 2 ECG. I will talk in detail, not a lot of detail, but just some important things about this paper and these boxes and how they are relevant and how they help us to calculate a variety of segment lengths, interval length, etc. So the first thing to remember in this whole complex diagram is that there are two types of squares. The squares which are joined by these dark red lines, this is a big square. And the ones which are joined by these small lines, this is red, but it's not, very much highlighted. So these are small squares. Because it's a square, the length is equal to the breadth. So the length of the big square is 5 mm, you can see here. And because it's a square, it means the breadth is also 5 millimeters. And the length of the small square is 1 millimeter, whether it's the length or the breadth. So this is the first thing to remember. Now, the second thing to remember that there are two axes. This is the x-axis if we move on this line, in this direction from left to right or from right to left. And the other axis is the y-axis if we move upside down. So on the x-axis, we have the time in milliseconds or seconds to be specifically. And on the y-axis, we have the voltage in millivolt. So the two big things are big squares, 5 by 5, small squares, 1 by 1, x-axis, time in seconds, y-axis, voltage in millivolt. Now, the small square represents 0.04 seconds if we tend to get a distance of 1 millimeter. So one small square is equal to 0.04 seconds. Reason being that the speed of the paper by which it moves on the ECG machine is 25 mm per second. And this speed, 25 mm per second, is set by convention. If it's not mentioned on any ECG paper, if somebody is randomly taking that ECG, you should be aware that this is 25 mm per second. There are conditions, abnormal arrhythmias, where we need to increase the speed of the paper to, let's say, 50 mm per second. In that case, this relationship 1 mm is equal to 0.04 may change. But for you, as a convention, and normally it's 25 mm per second, which gives 1 mm equal to 0.04. Now, if you see on the y-axis, this small square is equal to 0.1 MV or 0.1 millivolt. So which means if you have 1, 2, 3, 4, 5, or it should be 5 more, then it will be 10 MV or 1 volt, or this 5 constitute 0.5 millivolts. Now, you might be knowing, I'm just revising it for you. This is very simple. This P wave tells about the atrial depolarization. This QRS complex, the small q, the big R, and this negative S wave again. These three waves constitute ventricular depolarization, and this T wave constitutes ventricular repolarization. we don't have a wave which tells us about the atrial repolarization, and I can say that this wave has been occurring, but it has been obscured or occluded by this big QRS complex. So because it's occurring at the same time when depolarization is occurring, so we can see atrial repolarization because that's smaller than this wave, and this wave overshadows atrial repolarization. So P, atrial depolarization; QRS, ventricular depolarization; T wave, ventricular repolarization. One small thing which I want to add before we move on to the next slide is that there is a difference between a segment and an interval. Always remember that a segment won't have any wave. So it is always the axis, the x-axis into place. So if I'm measuring the distance between these 2 points, or maybe, yeah, these are 2 points only, so there is no wave in here. But if you see an interval, it is having a segment as well as a wave. So a combination of wave and segment is an interval. I mean, my whole idea is to let you familiarize with these terms as you see the ECG. Now, we are almost done with the ECG lead placement and the recording of a normal ECG. Now, let's move on to see the effect of exercise and a few pathological conditions on ECG and how ECG changes. Now, this is very simple. Whenever we do exercise, we have activation of sympathetic nervous system. You guys have been knowing it a lot because we have been learning the same thing in this lab and your other classes as well. So you have increased sympathetic activation, which increases a bunch of other things, which includes cardiac output, force of contraction, stroke volume, etc., etc. But heart rate definitely is increasing. So you have you do exercise, you have sympathetic activation, you have increased heart rate. And this increased heart rate can be visualized in an ECG. And there are two changes which takes place in an ECG while somebody is doing exercise. The first one is, of course, it's not shown very well in this ECG, but this small QRS complex duration, or the time on the x-axis, it gets shortens up once we do exercise. It's not very well depicted here, but this ECG below is normal ECG at rest with no exercise. The one on the top is when the person is doing exercise. So ideally, this duration should be more, this duration should be less. However, the second change is the RR interval duration is much shorter. So you can see in a resting one, we have one big block, two big blocks, three big blocks, and approximately fourth one, this one is not included, but if we include this one and add it here, so we have a difference of 4 big blocks, or 5 fours are 20, so we have 5 times 4, so we have 20 small squares between these two. But once we are doing exercise, you can see we have 2 big boxes instead of 4, or we have 10 small boxes, or 11, let's say, to be more precise, 11 small boxes. So basically this duration, the duration between the two the RR interval duration, or the difference between the two peaks of these R waves, this gets shortened up once we do exercise. So instead of 4 or 20 big or small squares, we have 2 or 10. These are the two changes which takes place once we do exercise. And I want you to know what an RR interval duration is, because you have to measure and calculate it for your data sheet assignment. Now, we are done with the ECG changes in exercise. Now we'll concentrate on the exercise-induced abnormalities. There are innumerable in number, but I just want to concentrate on the two big ones which are really important for you as exercise physiologists. The first one is the myocardial ischemia, and the second one is the myocardial infarction. I just want to highlight the difference between ischemia and infarction before we move on to this ECG. So whenever you have a decreased blood supply to any part of the heart, that part will not receive blood supply, and it will land into a condition of ischemia, which means that it's not getting blood. But it is still not dead. In infarction, when this ischemia or this condition of no blood supply continues for a time that the heart muscle is not able to sustain and dies, then the death of the tissue is known as infarction. So this is more serious, this is less serious. If there is ischemia and it can be reperfused, heart will become normal. If there is ischemia and it will lead to infarction and then there is a death of the tissue, even after reperfusing the blood supply, this will not get back to normal and this dead tissue will get sloughed off. So if you have a myocardial ischemia, you are likely to see ST segment depression. And if you remember, this is the P wave, this is the QRS complex, and this segment, if you remember, segment means we don't have waves. So it starts with the end of S wave and it ends with the start of the T wave. So between S and T, we have this ST segment. We have a depression of ST segment. So you can see that this ST segment depresses or goes down from this red neutral line. You can see it's just above the red neutral line. Here it goes down and it's going down 2 small squares, which means it's going down for approximately 0.2 MV. So if you have this kind of depression of ST segment, which moves from here to here, we have ST segment depression seen commonly in myocardial ischemia. Now, just opposite to this condition, we have the myocardial infarction. So here you can see this is the normal one. We already have seen that. You can see that this is the P wave, the QRS complex, and now instead of S segment coming down at this place, this whole stuff gets elevated. So this neutral line is here, and you have a box and a half elevation of this ST segment. So ideally it should be here on the isoelectric line or the neutral line, but it has moved up. So there is an elevation, and this is commonly seen in myocardial infarction. Now, this is just numbers, what we have talked. If the depression is more than 2 mm, you have to stop the exercise because this is myocardial ischemia. If this ST elevation is more than 1 mm, you again have to stop exercise because we have the myocardial infarction. So if you go back to the previous slide, depression of more than 2 mm and elevation of more than 1 mm are two big indications of stopping the exercise immediately, big red flag signs to stop the exercise. This is a kind of a recording which we are going to get once we'll do the exercise ECG in our lab. So this is lead 1, 2, 3, AVR, AVL, AVF, V1, V2, V3, V4, V5, V6. So we have these 6 chest leads, these 3 augmented leads, and these 3 bipolar leads, 1, 2, and 3. This is the last part of our discussion today, how we are going to do this lab activity 16.3. Guys, technically it's pretty simple. It's the ECG lead placement, which is a bit tricky, a bit challenging, I should say, but this is very simple. You have all the time given in the minutes. You don't have to do anything here. Speed is again set up, so we have to do the speed setup in the treadmill once we'll do the practical. Grading, again, I'll do it for you, so you don't have to bother anything about it. Just leave this power column because we are not calculating power in our ECG machine. We are bothered about this RR column 1, HR column 2, and just ignore this axis column because we are again not calculating the cardiac axis or the heart axis. And you have to bother about the RPE, which you have taken before as the rating of perceived exertion. So the idea is that you will get ECG just like this. So here you have an ECG for resting period, and you have ECG for stage 1, stage 2, stage 3 of the exercise, and a recovery period. So the idea is that I will print out hopefully 5 different ECGs, and you have to concentrate on lead 2 of every ECG and see and count. I'm repeating, please count in lead 2 ECG whether it's the rest ECG, stage 1 ECG, stage 2, stage 3, or the recovery, Small squares between those two are our consecutive RR peaks. For example, if I'm counting it here, 1, 2, 3, 5, 8 plus 3, 8, 8 plus 5, 13, 14, 15, 16. So I have 16 small squares in this ECG between these two consecutive R wave peaks. So you just have to, write this distance in millimeters, so you can write 16 here. And heart rate is 1500 upon RR interval. So if you got a value of 16 here, just put 16 here. So divide 1500 by 16 and you'll get a heart rate of, let's say, 100 or maybe 97 or 98 beats per minute. So this is how you have to fill these 5 columns and these 5 columns. So you will get a value of 16 or maybe 17 or less than 17, I guess, because once we are doing exercise, the R waves will become closer. So maybe we have a values of, let's say, 10 here. So we will write 10 here, and then it will become 150 beats per minute, the heart rate. And we are going to do it the same way. And once we have a recovery, let's say the recovery, the ECG for the recovery will be this one. And you can again count 5 plus 5, 10, 11, 12, 13, 14, 15. So you just have to go back, and put 15 here and then divide 15 by this. So you'll get a heart rate of 100 beats per minute. So you have to bother about 5 RR intervals for 5 different stages of ECG and use this formula to calculate 5 different heart rates, and RPE we will use as always using this card. Okay, this is the end of the presentation. Unfortunately, I don't have a slide to revise the things, but I want to, emphasize by, just to recapitulate the things for you. So we have talked initially about why we are doing ECG, why it's important. Then we have talked about the ECG lead placement. So we have talked about the bipolar lead placement, the unipolar lead placement, the chest leads and the augmented leads. Then we have talked about the ECG diagram or the picture. We have talked about the time on the x-axis, the voltage on the y-axis, about the small squares and the big squares. And then we have talked about the ECG changes during exercise and 2 pathological conditions, the myocardial ischemia and myocardial infarction. And at the end, we have talked about how to solve datasheet 16.3 using the formula of heart rate is equal to 1500 per RR interval, where RR interval represents the distance between the peak of 2 consecutive R waves, and you have to find the small number of squares between the two divided by 1500 to get the heart rate. I guess you'll be able to decipher something out of this presentation. I'll talk these things once more once we'll meet in the lab, and I hope we'll get some good ECGs on somebody, and then we have some good recording and you'll be able to fill in data sheets pretty easily. That's a great discussion today. Thank you very much, and I'll see you on Friday, I guess.